Welcome to Understand the Math. In this video, we're going to learn how to use matrix inverses to solve systems of equations. We'll go over the steps that you can follow and then walk through an example. Let's get started. I've written down some steps that we can follow to use matrix inverses to solve systems of equations. A system of equations can be written in terms of matrices. I want to show you how to do that. I have a system with two equations and two unknowns, and we're going to write it in terms of matrices. The first matrix that we're going to use is matrix A, and it's called a coefficient matrix because it contains the coefficients that multiply x and y. Those coefficients are 1 and 3. Now the 1's not written, so let's go ahead and let's put that. There's our 1. And then 2 and 4. So notice those go right into matrix A. The first column of matrix A contains the coefficients that multiply x, and then the second column contains the coefficients that multiply y. The second matrix is matrix X. Matrix X contains the variables that are in the system of equations. In our system, we have an x and a y, so we just put x and y into matrix X. The last matrix is matrix B, and that matrix contains the constants that are all by themselves in the system. When you write a system of equations in standard form, those constants are on the right-hand side. And we're just going to go ahead and put those in matrix B. AX is equal to B has a name, and it's called a matrix equation. Now let's go over the steps that we're going to use to solve a system of equations using an inverse matrix. The first step is to write the system as a matrix equation AX is equal to B. You now know how to do that. The second step is to find A inverse, which is the inverse of matrix A. I have a video on that if you need to review that concept. And then the third step is to solve for X. And the formula for X is equal to A inverse times B. If you go on to study linear algebra, you'll probably go through the derivation of this formula. Let's now walk through an example. I've written down a system of equations with two variables and two unknowns, and we're going to use an inverse matrix to solve this system. Let's start with the first step that's written up above. We are going to write our system as A times X is equal to B. Our A contains the coefficients that multiply X and Y, and that's 1, 2, 2, 3. You just line them up just as they are in the system above. Then we have our matrix X, which contains our variables X and Y. And then on our right-hand side, we have our constants, 5 and 8. Our second step is to find A inverse. So A inverse is equal to 1 divided by the determinant of A. Let's keep in mind that this is our matrix A. So we're going to find the determinant of that. It's 1 times 3 minus 2 times 2, that's just the main diagonal elements multiplied, minus the off diagonal elements multiplied. And then we have a matrix, and inside this matrix, we take the main diagonal elements that I highlighted in blue, and we switch them. So the 3 goes here, and the 1 goes here. And then our off diagonal elements, which I highlighted in pink, they get a negative. So we have a minus 2, and a minus 2. Let's compute what our determinant is. That is 3 minus 4, which is negative 1. So what's going to happen is we're going to bring that negative 1 inside our matrix, and every entry in our matrix is going to get a negative. So this is minus 3. We have a minus and negative 2 becomes positive 2. We have another positive 2 and then a minus 1. That's A inverse. Our third step is to find X, using the formula x is equal to A inverse times B. Our x is equal to A inverse, which we just calculated. That's minus 3, 2, 2, minus 1, times our B, and that was 5 and 8, just the constants from the right-hand side. Now we can go ahead and do some matrix multiplication. Let's look at the sizes of our matrices so we know what the size of our answer is going to be. We have a 2 by 2 matrix, and it's going to multiply a 2 by 1 matrix. That's because the matrix that has the 5 and the 8 in it has 2 rows and 1 column. We ignore these numbers, and we end up with a 2 by 1 matrix. Let's go ahead and let's find that now. To get the first entry, what we're going to do is we're going to multiply this row times this column, and that's going to give us a minus 3 times 5 plus 2 times 8. I have a video on matrix multiplication if you need to review that. Let's erase our highlights. And now we're going to take the second row times this column. So we have 2 times 5 minus 1 times 8. This is equal to minus 15 plus 16 on our first row. And then the second row is 10 minus 8. We're kind of running out of space here. Let me do an arrow and let's put our answer up top. This is equal to minus 15 plus 16 is 1, and then 10 minus 8 is 2. I always tell my students, whenever you write down an answer, it needs to be in the form that you were given originally. We were given x and y, so let's write our solution in terms of x and y. So we can say that x is equal to 1 and y is equal to 2, or you can just write it as 1, 2. And that's it. You now know how to use matrix inverses to solve systems of equations.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.